The topic is combinational and sequential logic circuits. Introduction. Digital circuits are of main of two types, combinational circuits and sequential circuits. The main difference lies in whether the output depends only on present input or both present inputs and past inputs. In digital circuits, we have mainly two main types. There are combinational circuits and sequential circuits. The difference is about output depends on present inputs or both present inputs and past inputs, like of sum of memory. Combinational logic circuits. A combinational circuit is a logic circuit whose output depends only on the present input value, not on any past or future inputs. This is about combinational logic circuits. There is a no memory element in such circuits. The basic concept of combinational logic circuit is the combinational circuit only depends upon present input values. It doesn't care about the previous and past like future inputs. Basic concepts of combinational logic circuits are these circuits use logic gates like AND gate, OR gate, NOT, NAND, NOR, XOR and XNOR to perform logical operations. Characteristics of combinational logic circuits. Output depends only on current input, no feedback from output to input. No memory elements, cannot store information. Faster operation since no clock is required. Here, in combinational logic circuits, there is no need of clock. Designed using Boolean algebra and truth tables. These can be designed by using Boolean algebra and truth tables. The block diagram of combinational circuits are input, logic gates, output. Input, by performing in logic gates, we get output. If example, F is equals to A dot B plus A bar dot C. The output depends only on A, B and C. Only on current inputs like A, B, C. It does not depend on future inputs or at least past inputs. This is the characteristics of combinational circuits. Examples of combinational circuits. Circuit adder. Circuit adder. It performs arithmetic function, adds binary number. Subtractor. It is also an arithmetic function, subtracts binary number. Multiplexer. The short name of multiplexer is mux. It is a data selection function. Selects one input among many inputs. Demultiplexer. Demux. Data distribution. Send one input to many outputs. Encoder. Data conversion. The function of encoder is data conversion. Converts input to coded binary. Next circuit is decoder. The decoded data conversion converts binary code to output. Comparator. The function of the comparator is logic comparison, compares two binary numbers. These are the examples of combinational circuits and their function and their description. A sequential logic circuit. The definition of the sequential logic circuit is one in which the output depends on both the current inputs and past history of inputs. These circuits have memory elements that stores information. Basic concept. Sequential circuit use feedback paths to store data. The memory elements are typically flip-flops or latches. They operate in synchronization with a clock signal. Here in a sequential logic circuit, we have clock. But in combinational logic circuits, we do not have clock. Characteristics of sequential circuits. Output depends upon current input and previous states. Contains memory elements, example flip-flops. Requires a clock for synchronization. Can perform time-dependent operations. Can store binary data 1 or 0. Here, the characteristics of sequential circuit is here the sequential circuits need clock for synchronization. It can store the binary data 1 or 0. Types of sequential circuits. Sequential circuits, synchronized sequential circuits operates according to a clock signal. States change occurs only on clock pulses. Example flip-flops, resistor counters. Asynchronous sequential circuits do not use a clock state changes occurs immediately after input changes. Do not use a clock, but immediately after input changes, it also changes. Example ripple counters. This is about the types of sequential circuits. We have synchronous and asynchronous circuits. Components of sequential circuits. Combinational circuit performs logic operations. Memory element store past information like flip-flops. Clock signal controls timing. Feedback path connects output to input. Types of flip-flops. We have mainly four types of flip-flops: SR flip-flop, JK flip-flop, D flip-flop, T flip-flop. The input functions of SR flip-flop flip-flop is set reset. The basic function of SR flip-flop is basic storage element. JK flip-flop. Here the inputs are JK eliminates invalid state of SR. This is the function of JK flip-flop. D flip-flop. The input of D flip-flop and the main aim of D flip-flop is it stores the data. Transfer input to output on a clock. T flip-flop. Here the state of the T flip-flop is toggle and the input of the signal is input of the flip-flop is also toggle. Here the function is changes state on each clock pulse. Applications. Applications of combinational logic circuits and sequential logic circuits. Applications of combinational logic circuits are arithmetic operations, data routing, port conversion, comparators, logic circuit, logic control units. Sequential circuits. The applications of sequential circuits are memory storage, counters, shift registers, timer, and clocks, and also state machines. The state machines have different history. The state machines contains like finite machines, morely, like some other machines. These are the applications of sequential logic circuits and combinational logic circuits. We can discuss about the differences of these circuits. Here, for a combinational logic circuit, the output depends only on present input. But in the sequential logic circuits, output depends upon present input plus past inputs also. No memory element is used in combinational logic circuits. Memory element like flip-flops are used. Do not require clocks in the combinational logic circuits. In sequential logic circuits, we always require the clock signal to update states. To update states in sequential logic circuits, we use clocks. Faster operations because no feedback. We need faster operation because there is no feedback in combinational logic circuits. Slower due to clock and feedback. Here in sequential logic circuits, we perform feedback also, so it takes slow time. Represented using logic gates like AND, OR, NOT, XOR. In combinational logic circuits, in sequential logic circuits, it is built using logic gates plus memory elements like flip-flops, registers, counters. Registers, counters and flip-flops are the main examples of sequential logic circuits. Output changes as soon as input changes. In the combinational logic circuit, as input changes, the output also changes. But in the sequential logic circuit, output changes only at clock edges. Examples of combinational logic circuits: adders, subtractors, encoders, decoders, multiplexers, and etc. Examples of sequential logic circuits are counters, shift registers, finite state machines. No concept of past, future, no concept of no concept of easy to design and test. Complex design due to timing and states. No concept of past or future state. Has past state and next state from a state machine. Errors occurs due to glitches. In combinational logic circuits, error may occur due to time violation, setup, and hold times. These are the main differences of combinational logic circuits and sequential logic circuits. In digital logic circuits, these combinational and sequential logic circuits plays main role for construction of any logic circuits. In digital logic circuits, there are so many examples like flip-flops, registers, counters, etc. etc. These all are maintained by these combinational circuits and sequential circuits. By compared to combinational circuits, sequential circuits are little more complex than combinational circuits. Conclusion. Combinational circuits perform operations based only on present input. Sequential circuits depend on both present input and previous state. Thus, providing memory and control together, they form the basic of digital computer processors and control system. The final conclusion of these combinational and sequential logic circuits is the inputs are only based on the present input is known as combinational logic circuits, and the input that are based on present input and past input, these are known as sequential logic circuits. By these we can design so many circuits we have discussed in this video. That's all for this video. Thank you.